Welcome back to the 2014 SSEP National Conference. And I would like to now start the final block of oral presentations with Oral 9, which is Howard County, Maryland Mission 3A Flight Experiment.
Good afternoon. My name is Josh Choi. This is Sophia Novacek. And our project was titled The Effect of Microgravity on Chryseobacterium aquaticum Growth.
The students that conducted this project were Josh Choi, Greg Nelson, Ryan Olson, and myself, Sophia Novacek. Next slide, please.
Chryseobacterium aquaticum is a bacteria that produces an antifungal protease that promotes plant growth. Therefore, it acts as both an antifungal protection and a fertilizer for plants. This is beneficial because if Chryseobacterium aquaticum successfully grows in space, it may be able to promote plant growth in space as well.
We hypothesized that the lack of microgravity would encourage more rapid growth in Chryseobacterium aquaticum.
2 identical vials were filled with equal amounts of Chryseobacterium aquaticum, nutrient agar, and formalin. The first vial was designated to go to space, and the second one was to stay on Earth. Next slide, please. And that's what the vials looked like. Next slide, please.
The space vial and the Earth vial, as Josh said earlier, both contain the same amount of nutrient agar and broth. These were cracked simultaneously and released into the vial. Next slide, please.
To isolate the factor of microgravity on the rate of Chryseobacterium aquaticum growth, the Earth vial was treated to simulate the extraneous factors that were put on the space vial to eliminate inaccurate data. For example, the Earth vial was shaken up to simulate the G-forces that the space vial experienced on the flight. Next slide, please.
To test the rate of growth for our bacteria, we ran a spectrometer reading. This tests the density of the solution that returned back to Earth by shining a beam of light through it and determining the density by measuring how much light came out the other side. Next slide, please. As you can see here, the spectrometer shines light through our substance that returned to Earth from space, and it measures the amount of light that was shown through the other side. This determines the density of our bacteria and helps us determine whether it grew more or less or not at all. Next slide, please.
The spectrometer showed that Chryseobacterium aquaticum not only survived in space, but grew even better. As you can see from our final mass data, the Earth mass was 25.4061 grams, and the space mass was 25.4737 grams. Next slide, please. And that's just a picture of our space flight. Next slide, please.
Without these companies, we would not be able to be here today presenting our winning project. We would also like to give special thanks to Dr. Jung Suk Lee of the Korean Collection for Type Cultures for providing us with our bacteria. And we'd also like to give special thanks to Sydney Kaufman and Cindy Keller at the Applied Research Laboratory in Howard County, Maryland. And lastly, we would like to give the most thanks to our teachers who helped us, Miss Lauren Landerman and Miss Ella Jordan. Thank you. This concludes our presentation.
Are there questions for the Howard County team? Okay, let's thank Howard County one more time.